Today we're going to determine what factors affect and influence chlorophyll A levels in 3 temperate stations. Chlorophyll allows plants, including algae, to photosynthesize, use sunlight to convert simple molecules into organic compounds. One of the symptoms of degraded water quality condition is the increase of biomass measured by the concentration of chlorophyll A. We are going to take a look at how the chlorophyll concentrations in the temperate zones data plays a role in primary productivity. At the base of the ocean food web are single-celled algae and other plant-like organisms known as phytoplankton. Like plants on land, phytoplankton use chlorophyll and other light-harvesting pigments to carry out photosynthesis. Where phytoplankton grow depends on available sunlight, temperature, nutrient levels. These phytoplankton are also known as our primary producers. Primary productivity varies both geographically and seasonally. Geographically, phytoplankton abundance generally decreases as you move from coastal to oceanic waters. Coastal waters are more productive than the Central Ocean for 2 main reasons. First, the runoff from land often contains a high abundance of nutrients, which gets deposited in coastal waters and stimulates production. Second, the shallow bottom along the continental shelf can trap nutrients and prevent them from sinking to greater depths. It is easier for these nutrients to be brought back to the surface where they remain trapped in the shallows. Conversely, the Central Ocean generally has a very low primary production, as these areas are far removed from any terrestrial source of nutrients, and the great depth prevents the deep nutrients from reaching the surface. Regional and seasonal changes in primary production are due to a combination of the availability of light and the amount of nutrients provided by water mixing above the thermocline. In tropical regions, sunlight is plentiful throughout the year, so light is not a limiting factor. The surface water is always warm, and there's patterns of primary production and always a pronounced thermocline, leading to highly stratified water that prevents the nutrient-rich bottom water from reaching the surface. Thus, productivity in tropical waters is always nutrient limited and productivity is low throughout the year. Because cold water tend to have more nutrients than warm waters, phytoplankton tend to be more plentiful where waters are cold. The highest chlorophyll concentration, where tiny surface-dwelling ocean plants are thriving, are in cold polar waters or in places where ocean currents bring cold water to the surface, such as around the equator and along the shores of continents. Also, when surface waters are cold, it is easier for deeper water to rise to the surface, bringing nutrients to sunlit areas where phytoplanktons can use them. As you can see here indicated by this data, this blue line here is going to be the endurance array. As we can see, the chlorophyll levels are fairly high. Yellow is going to be the Pioneer array located in the North Atlantic. We see here that they have some bursts of chlorophyll A counts, but stay fairly steady throughout the time period. And the Argentine South Atlantic, as indicated by the green, shows a fairly low and steady chlorophyll concentration in the data range that we are looking at. The endurance rate is located on the Oregon coastline. Between April 2015 and August 2015, there were extremely high levels of chlorophyll A, which indicates cooler waters, temperature increase, decrease in dissolved oxygen and salinity, and increased nitrate concentrations. These levels are collected by 2 cross-shelf moraid array lines. Gliders move and collect data around, along, and between these lines. Fixed sensors at the top and bottom of the water column paired with adjacent water column profiler. The Pioneer array, located in the North Atlantic, is located off the coast of New England. Between April 2015 and August 2015, there were fairly consistent low levels of chlorophyll, which is indicative of warmer water, temperature decrease, increased and dissolved oxygen and salinity, and decreased nitrate levels. The methods used at this station are moorings supplemented by 6 coastal gliders, 2 profiling gliders, and 2 autonomous underwater vehicles. Coastal gliders monitor the slope sea and outer shelf, resolving Gulf Stream rings, eddies, and meanders. Profiling gliders are used as virtual moorings at the central and inshore sites in the summer. The next station is the Argentine Basin Array, located in the South Atlantic off of the coast of Argentina. We also see between April and 2015 that there were consistent low levels of chlorophyll, which again is indicated of warmer water, temperature decrease, increase in dissolved salinity and oxygen, and decrease in nitrates levels. Their methods consist of a triangular set of moorings with the sides of the triangle having a length roughly 10 times the water depth to capture mesoscale variability in each region. The harmful algal blooms, as we see in the endurance data, are referred to as HOBs. HOBs can occur for a number of different reasons, although a common one is an overabundance of nutrients, which is often due to excessive terrestrial runoff of fertilizers or other nitrogen and phosphate-containing materials. These conditions lead to an explosion in algae populations that can change the color of the water if the cells are high enough in high enough concentrations. When all of this algae eventually dies off and sinks, their decomposition uses up the dissolved oxygen in the water, leaving anoxic or hypoxic conditions that can lead to mass die-off of fish and invertebrates. Many factors go into affecting productivity, including light, temperature, nutrients, soils, and water. Although the phytoplankton are microscopic in size compared to marine plants and macroalgae like seaweeds and seagrasses, they account for by far the greatest amount of photosynthesis in the ocean, about 95% of all marine primary productivity. Most of the production by phytoplankton comes from the groups the diatom, dinoflagellates, and coccolithores. Ocean primary productivity obviously forms the base of marine food webs, but it also produces about half the oxygen that we breathe in terrestrial systems. This leads us to the conclusion to believe that the best physical and chemical indicators for an increase in fluorescence and less plankton growing is higher temperatures, high nitrates, lower dissolved oxygen, and lower salinities.